Welcome to Mona Tutorials, and in this session we'll be discussing shaders. We'll be taking a look at what shaders are, what you can do with them, how Unity uses them, and what shader code actually looks like. Let's jump right in. A shader is a program or some code that is executed on a computer's graphics processor. These shaders are executed during various stages of the rendering process. So there are a couple important parts of that definition that we should take note of. So first off, we see that shaders are run on a computer's GPU, or graphics processing unit. That's important because GPUs are very good at running complex mathematical operations in parallel, or at the same time. So the second important part is that different shaders are run during different stages of the rendering process, and each shader has a different purpose. So let's go ahead and look at a couple of these stages. The two most commonly programmed shader stages are vertex shaders and fragment shaders. The goal of a shader in either of these stages is to take some input passed to it from the previous stage, operate on that information, and pass the result to the next stage. So let's look at an example of this. A vertex shader is designed to process vertex data. It receives information about each vertex from the main program and will typically adjust the position of each vertex as necessary, as well as define texture coordinates. Once the vertex shader has finished, the results of its calculations can be used in a fragment shader. A fragment shader, also known as a pixel shader, is used to determine the color of each pixel on the screen. To do this, it utilizes both the information it receives from the vertex shader, and it also uses information such as where the pixel is located on the screen. So let's go ahead and sum all of that up. So we now know that shaders are programs executed on the GPU in separate stages. The GPU is used for this task to allow for those operations to be run in parallel, and each stage takes some information from the last stage, operates on it, and produces an output. The vertex shader is executed once for every vertex, and every vertex is processed at the same time. And then likewise, the fragment shader is executed once for every pixel, and each pixel is also processed at the same time. Now that we know what shaders are, let's take a look at some of the things we can do with shaders. The most common purpose for shaders is to digitally recreate the effects of lighting, things like shadows, specular highlights, and reflections. Because most natural lighting can be simulated using simple linear algebra, shaders are perfectly suited to tackle those problems. Shaders can also be used to produce many different visual effects, ranging from simple color changes and tone mapping to more complex things like bloom, motion blur, and vertex displacement for foliage or water. Let's jump into Unity and take a look at how Unity uses shaders. Most likely you've encountered shaders in the form of materials. So let's look at a material I created here. So materials are typically used to define the way a surface of an object in Unity looks. And you'll notice at the top here, we can actually change a shader. So the shader option on material lets you define the actual shader code that is used to create the look of a material. So in this case, this is just the standard shader. And you can see it provides basic lighting, shadowing, other simple effects that you expect from a surface. But we can change this. Maybe I want it to be unlit. I don't want there to be any light at all. I will go ahead and set this to just an unlit color. And now all these objects that have this material on them are using the unlit shader or unlit color shader. And you can tell now there is no lighting on these objects whatsoever. And all I get now is just a color that I can define for them. So now let's look at what the shader for this might actually look like. So I can go down here in my project field, go to create shader, and I'm going to create an unlit shader, just so it'll match what these objects look like. Right, let's open that. And we can take a look at the code here. It seems very complex. There's a lot of stuff here. And I'm not going to go too in-depth into what any of this means, but I will point out in this one file, we actually have both of our shader stages we talked about earlier. We have a vertex stage right here, and we have a fragment stage right here. Now, for most people, if you're not a programmer, this is even more confusing, especially if you've never seen code before. So thankfully, people have made resources that we can use to actually make it simpler to create shaders. So let's go back to Unity, and I am using, or I have installed, a tool called Amplify Shader Editor. You've probably heard of it. And Amplify is used to graphically create shaders, so in a way that's more easier to visually understand. So what I'm going to do is I'm going to, with Amplify installed, open this in the Amplify Shader Editor install instead. And you can see it's much simpler. There's no code, and Amplify lets me do things like create nodes, maybe for if I want just a color. I'll put a color here, connect that, maybe change the color, and I can very simply just create a shader. If I save this and close out of it, now my shader has changed. So now I can go back to my material and switch the shader to the one that I just created, which should be in here now. Search for it. There it is. And you can see now these objects match the shader I created. Cool. So that was a short introduction on how to use shaders in Unity. Hopefully that helps you just understand a little bit better about what shaders are and how they're used. And yeah, we'll have some more tutorials in the future about actually creating shaders, using these concepts and applying them to create unique effects. So yeah, I'll see you then.